Okay, so 19.3, we are going to be translating our trig graphs. Okay, so now we're going to include shifts of left or right and up and down. Okay, so you can see the general form for all three of these. We're only going to be drawing sine, cosine, and tangent. All three of those forms are identical other than the trig functions it's relating to. Okay, so I'll give you a second to write that down, and then we're going to go straight into an example. Okay, you guys ready? Moving on? No. Okay, so as we go through this, I'm just going to do an example. And so it would probably be really smart for you to give yourself like little side notes as to how information is found. Okay, so try to make really detailed like sequential steps for this. Everybody ready? Let's do it. All right, let's do this equation right here. Nope, let's not do that one. I lied. Let's do... Whew. Oh, we're in the wrong problem. Hold on. First, get to the right class. There we go. There we go. All right, so this is the equation we're going to do first. It's not my most favorite example for the start, but it'll work. Okay, so we have 0.5 times the sine of 3 times the quantity x minus pi over 3 minus 1.5. Okay, so the first thing that I'm going to do, and I would expect for you to do as well, on each of these graphs is to identify each of the important pieces. Okay, so I want you to list amplitude. I want you to find your b so you can find the period. Okay, and then additional shifts that there may or may not be. Okay, so for starters, what's the amplitude of this? 1/2, right? So 0.5. I like that you said 1/2 though. Okay, what is my b value? Ooh, be careful, good. Okay, so remember that this 3 has been reciprocated. Okay, by definition it's 1 over b, so your b is still going to be a reciprocal of what you see. Okay, so once I find my b, I'm going to go straight to the period. Okay, remember that when we're working with sine and cosine, what is the period? Good, 2 pi times b. Okay, so remember there's a difference between sine and cosine versus tangent. Tangent's period is just pi times b. Okay, so don't forget that. So if we have 2 pi times 1/3, what would that give us? 2 pi over 3, good. So that's our period. Okay, so that is the distance that it's going to take for us to draw one full cycle of the wave. Remember the sine function looks like this. Remember that? Okay, so that's what we're drawing. Okay, the next thing that we're going to draw or write down is our translations. Okay, so up in the exponent, or not the exponent, up in the parentheses, I have a minus pi over 3. So what direction is that going to shift us? To the right. Okay, so we're going to shift to the right, pi over 3, and then what is the minus 1.5 going to do at the end? Down. So down 1.5. Okay, so once I have all this information, I can go to the graph. Okay, now the first thing that I'm going to draw when we have a vertical shift, so an up or down movement, is I'm going to draw what I'm going to call the midline. Okay, so do you remember that when we were drawing all of these sine functions, they would start right on the x-axis, go to a maximum, and then come back and cross the x-axis, and then go to a minimum, and then back to it? Okay, well when we shift things up and down, we want to still have that reference. Okay, so I'm going to draw a midline, and the midline is just strictly going to be the k value. Okay, so my k value is moved down 1.5. So I'm going to use a little dotted line. It's not an asymptote. This is just a midline to help me reference points. Oops, midpoint I just wrote. Midline. There we go. Okay. Okay, so now I want to think about where sine functions start. Okay, if I was just going to draw a plain old generic sine function, where would it start at? Okay, right at 0, 0. Okay, so I'm going to imagine starting at 0, 0, and then I'm going to do the two translations that I've got. Okay, so if I start at 0, 0, what are the two shifts I'm going to take? To the right, pi over 3, and then what? Down 1.5. So did everybody land exactly at the points pi over 3 and negative 1.5? Everybody okay with that starting position? So we're going to call that the start. Good there? Okay, so the next thing that I want to do is I want to draw my ending point. Okay, so do you remember how you find an ending point on our sine functions? The period, very good. Okay, so I'm going to go to the period, and then I'm just going to do the same shifts. Okay, so my period was initially 2 pi over 3, so yeah, 2 pi over 3. Okay, what are my two translations? To the right, pi over 3. Okay, so now when I think about doing this, okay, so I'm going to go from 2 pi over 3. Pi over 3 is how far? Like how many increments is that? 2 increments. So when I'm thinking about this, I'm just going to say, I'm just going to move this 2 increments to the right. So that's a distance of pi over 3. And then I'm going to go down 1.5. So where exactly did I land? What spot? Good. So pi and negative 1.5. So that's my ending place, my ending point. Oops. Can't spell today. Okay, now what can I do? Some stuff. Okay, we find the midpoint from there, right? Okay, so remember, when we draw the sine curve, okay, the midpoint is exactly in the middle of our start and our end. Okay, so what is the point that's exactly in the middle of the start and the end? 2 pi over 3, good. Okay, so it still exists right on the midline. See how helpful that midline is? So 2 pi over 3, we're still at negative 1.5. Okay, let's find a maximum. Okay, so our maximum is going to occur halfway between the start and the midpoint. Okay, so if I'm looking at my start and my midpoint, what is the place that is exactly halfway between pi over 3 and 2 pi over 3? Pi over 2. Okay, and if I'm doing a max, I have to go up a certain distance. How high am I going to go up? Okay, so the amplitude, right? So remember, make sure you take a close look at your increments. If I have to go up 0.5, that's a distance we're going by 0.5. So that's a distance of 1 increment. What is the exact point I just landed at? Good. Pi over 2, negative 1. Okay, now let's do the minimum point. Okay, so minimum is going to exist exactly between the middle and the end. Okay, so what's my x value going to be? 5 pi over 6, and then I have to go down 0.5, so where is that going to land? Good. Okay, so once I have those 5 points, I'm just going to draw my pretty little sine curve. Make sure it looks wavy, not like rigid. Okay, and that's all I'm going to have you draw. But everybody remembers that if I type this function into the calculator, it wouldn't look like that. What would I see? A wave, right? Okay, the wave would go exactly through the points that I drew, but just remember, we're just drawing a small little section of that wave. Okay? Pretty good there? Shall we try another one? Should we do like a tangent one? Okay, let's do a tangent one. Let's see. There we go. This one will work. So let's do this right here. Okay, so that says 2 times the tangent of 1/2 times the quantity of x plus pi, and then plus 3 at the end. Okay, so now all we're going to do is we're going to take that information that we just did with our tangents, and then we'll take all that and we'll do our shifts. So we'll move it up or down, and then we'll shift it left or right, whatever we got to do. Okay, so first thing I want to list, what's my amplitude? 2, the number in the front, right? What's my b-value? 2, good. What's my period? 2 pi, good. So remember, you just multiply by pi with tangent. Okay. Let's talk about our shifts. If I have plus pi up in the parentheses, what direction is it going to take us? To the left. So we're going left pi, and then plus 3 is going to move us up 3. Okay, so these are the shifts. I'm going to like bubble this because we're going to take all of our information basically and do those shifts. Okay, so remember with tangent we have to talk about our vertical asymptotes. Okay, so I'm going to start by just simply identifying our vertical asymptotes that would exist before the shifts. Okay, so where would my vertical asymptotes be for this one? Good, plus or minus pi, everybody okay with that? Taking the period and dividing by 2. Okay, where would my reference points be? So negative pi over 2, right? And then since I have a right arm up of my John Travolta, right? My left arm is going to be down, so what's my y-coordinate at that point going to be? Negative 2, good. Okay, then I would have 0, 0, and then basically my right arm is going to be the positive version there. Okay, now remember that all of these things that I just wrote down are pre-shift. Okay, so what I have to do to find the actual points is find those, and then we'll shift them whatever directions we got. Okay, so we're going to go left pi and up 3. Okay, all right, what's the first thing I want you to draw? The midline. Okay, so the midline for us is where? Up 3, okay? It's just your vertical shift. So we're going to start by drawing that midline. So remember the midline when you're working with tangent is going to be where that function does its little wiggle, okay? Now, there's kind of 2 ways to do this. We can like literally think of the shift and like where it lands, or we can start with the starting points and shift them. Okay, so I think what I'm going to do is I'm going to start with the starting spots and then just shift and do it that way. If you can go straight to where it shifts to, that's totally fine. It's up to you. Okay, so if I was going to draw the first vertical asymptote, we would have one that would exist at negative pi, right? Okay, so if I take negative pi and I have to go to the left pi over 3, where am I going to land? Oh, I said that wrong. Sorry, left pi. Not over 3 pi. There is a 3 there, but it's not related to our left shift. My bad. So to the left pi and negative 2 pi. Good. Okay, so going to the left pi. Okay, and I'd like for you to identify that on your graph. So we have a vertical asymptote at x equals negative 2 pi. Okay. Then let's do our asymptote that was on the right. Okay, so this one would have started at pi, and if we shift pi to the left pi units, where do I land? Exactly at 0. Okay, so going from the left pi units, we're right at 0. So we have another vertical asymptote at x equals 0. Okay, so now I'm going to take my points. Okay, so I'm going to start with my first point, that is at negative pi over 2 and negative 2. Okay, and I have to do 2 shifts here. What are my 2 movements that I'm going to make? Left pi, and if you want to think of like how far it is as far as increments, notice that the distance of pi is 4 increments. Okay, so I'm going to take this pi over 2 and go 4 increments to the left, right? 1, 2, 3, 4, so I'm right here. And then what's my vertical shift? Up 3, so 1, 2, 3. So where did I land exactly? What was that spot? What did you guys get? So did you get negative 3 pi over 2, positive 1? Okay. Now the center point, don't you think this one is probably the easiest? And some of you guys like immediately went right to it. This origin spot is going to go straight to whatever your shift is, right? Okay, so where is my little center point going to land? Negative pi up 3, right? So that one should be pretty straightforward, I should hope. Negative pi 3. Okay, and then from there, we can start with our positive pi over 2 and 2, so that's going to be right here. Okay, so I'm going to shift it to the left pi, which is 4 increments. 1, 2, 3, 4. And then I'm going to go up 3 from there. 1, 2, 3. Where did I land? Did you land at negative pi over 2 and 5? Okay, good. So then, to the best of your ability, draw a beautiful John Travolta through those. Voila. How do you feel about this? Do you want another example? Feeling good. So you guys look at this and be like, man, look at how smart we are. Like, that's pretty complicated stuff to graph and be that precise. I bet if your parents saw that, they'd be like, wow,